Dear students, warm welcome to the module on chatelier principle. In this module, you are going to study about the different factors affecting the chemical equilibrium and how these factors affecting the equilibrium. The effect of various factors such as concentration, temperature and pressure can be stated in the form of a principle called chatelier principle. The principle states that if a system in equilibrium is subjected to a change in concentration, pressure and temperature, the system or the equilibrium will shift in the direction that tends to reduce the effect. This principle is known as chatelier principle. We already found that at equilibrium, the measurable properties of the system, that is concentration, temperature, pressure, etc., are found to be constant. If we change any of these properties, that will affect the equilibrium. First, we shall think about the effect of change in concentration. In a chemical reaction, we know that there are reactants and products are present. We can change the concentration of products or reactants, and the corresponding change may be of two types. That is, addition or removal of the products or reactant. So, altogether 4 cases will be there related to the change in concentration. Can you say what are these changes? Yes, they are addition of reactants to the reaction mixture, addition of product to the reaction mixture or equilibrium mixture, removal of the product from the equilibrium mixture, removal of reactant from the equilibrium mixture. Now, we shall think what will happen if we change the concentration. Let us assume that the equilibrium is a balanced stage as showing the picture. Now, you have to say if we add some substance to on one side of the balance, how it can reach to the balanced state again without the addition of substance on the other side. I will explain it. This is the case similar to the equilibrium. At equilibrium, the reaction mixture contains both reactants and products. And we know that the equilibrium is dynamic in nature. When we add any one of the reactant or product, it will combine with the remaining reactant or product, then the equilibrium mixture and form products or reactant, and thereby maintaining the equilibrium. In short, we can say that when we add reactants to the reaction mixture, the equilibrium moves in the forward direction. If we add products to the reaction mixture, equilibrium moves in the backward direction. So, we can say that on increasing the concentration of any of one of the product or reactant, the equilibrium will try to reduce its concentration by moving the direction in which it is decreased. That means, on addition of product, the equilibrium shift in the direction of backward one. Let us see another case. If we are removing the products from the equilibrium system, what will happen? On removing the products, the concentration of product in the equilibrium mixture decreases. So, in order to attain the equilibrium stage, the reactant will convert it to product. So, on removing the products, equilibrium shifting the forward direction. If we removing the reactants from the system, equilibrium will move in the backward direction. So, I ask one question to you. Consider the formation of ammonia as example. The reaction is nitrogen plus hydrogen gives NH3 ammonia. So, can you say how can we increase the amount of ammonia in the equilibrium mixture? One way is adding nitrogen to the reaction mixture or adding hydrogen to the reaction mixture. Both of them are reactant. Another way is if we remove the ammonia from the equilibrium reaction mixture, we can increase the production of ammonia. Next, we shall discuss the effect of pressure on equilibrium. Let us think what will happen if we increase the pressure. Let us consider the case of a gas enclosed in a cylinder, and on increasing pressure, what will happen? Yes, the volume will decrease, which will result in the increase in number of moles per unit volume or concentration change. So, according to Le Chatelier principle, on increasing the pressure of the system, the equilibrium will try to reduce its effect. To maintain the equilibrium, the system will try to decrease the number of moles per unit volume. So, the reaction proceeds in the direction in which number of moles decreasing. So, a system in equilibrium, on increasing the pressure, the system will move the direction in which number of moles decreasing. That is the effect of pressure. If we decrease the pressure, the equilibrium move in the direction in which number of moles increasing. Let us take one example of ammonia formation. We can write the equation. The equation is N2 gas plus 3H2 gas gives 2NH3. Can you say what is the total number of moles of reactant, gaseous reactant? Yes, nitrogen is 1, hydrogen is 3, so total 4 moles are present in the equation. In the case of ammonia, you can see only 2 moles. So, on increasing pressure, we found that according to Le Chatelier principle, the system will move in the direction in which number of moles decreasing. So, in the case of ammonia, on increasing, the system will move in the direction of formation of ammonia. So, we can say that formation of ammonia is favored by increasing the pressure. And if we decrease the pressure, equilibrium will shift in the backward direction. That means decomposition of ammonia will take place. This is the effect of pressure on equilibrium system. Now we shall discuss the effect of temperature on equilibrium. We already discussed about the change in concentration, pressure and its effect on equilibrium. When we changing the concentration or pressure, the composition of equilibrium mixture changes, which affect the reaction quotient, that means QC. So, QC will never be equal to equilibrium constant Kc. But when we change the temperature, the value of equilibrium constant itself is changed. In general, we can say that the temperature depends on equilibrium constant, that depends on sign of delta H for the reaction. Delta H means change in enthalpy for the reaction. If delta H is negative, such type of reactions are called exothermic reaction. If delta H is positive, then the reaction is called endothermic reaction. The equilibrium constant for an exothermic reaction, that is having negative delta H, decreases as the temperature increases. The equilibrium constant for an endothermic reaction, that is having positive delta H, increases as the temperature increases. From this, we can find out the effect of temperature. Temperature changes affect the equilibrium constant and the rate of reaction. On increasing the temperature, the equilibrium shift in the direction of endothermic reaction. On decreasing the temperature, the equilibrium shift in the direction of exothermic reaction. Let us take the example of ammonia formation. Here the equation is N2 plus 3H2 gives 2NH3. Delta H is equal to minus 92.4 kilojoule per mole. So we can say that forward reaction, that is formation of ammonia, is exothermic in nature. We already found that on decreasing the temperature, the equilibrium shift in the direction of exothermic reaction. So for the formation of ammonia, we have to decrease the temperature. So decreased temperature or decreasing the temperature will favor the formation of ammonia because forward reaction is exothermic one. On increasing the temperature, what will happen? It will result in the decomposition of ammonia. This is the effect of temperature. Now we shall study the effect of addition of inert gas. If the volume of the system is kept constant and an inert gas such as argon is added to it, due to the innate nature, it does not take part in the reaction. The equilibrium remains undisturbed. So we learned about the effect of change in concentration, pressure, temperature, and effect of addition of inert gas on equilibrium. Now we shall study the effect of catalyst. What is meant by catalyst? Catalysts are the substance which generally increase the rate of a chemical reaction. How we can increase the rate of a chemical reaction? By providing an alternate pathway for the reaction having lower energy. So by adding the catalyst to a equilibrium mixture, it can increase the rate of both forward reaction and backward reaction. So the catalyst does not affect the equilibrium composition. So in this module, you all studied about the Le Chatelier principle and the factors that affect the equilibrium. Hope you all understood about it. Thank you, students. Thank you. We will meet in the next class.